Magnetism and electromagnetism. Permanent and induced magnets. A permanent magnet makes its own magnetic field all the time. It has a north pole and a south pole, and you can't have one without the other. Like poles repel, two norths or two souths push apart, and opposite poles attract, a north and a south pole together. An induced magnet is different. It's a magnetic material, like iron, that only becomes a magnet when you put it into a magnetic field. The tricky bit to remember, an induced magnet is always attracted to the permanent magnet, never repelled. And when you take it out of the field, it quickly loses most of its magnetism. That's why a magnet can pick up a chain of paper clips. Each clip becomes an induced magnet for a moment. The only magnetic materials are iron, steel, cobalt, and nickel. So in the exam, if it's not one of those, it's not magnetic. Magnetic fields. A magnetic field is the region around a magnet where it can affect another magnet or a magnetic material. We draw it with field lines. The rules are that the field lines always point from north to south outside the magnet. They never cross, and the closer together they are, the stronger the field. So the field is strongest at the poles, where the lines are most bunched up. You can find the shape of a field with a small plotting compass. Because a compass needle is itself a tiny magnet, so it lines up along the field line. A compass is also the evidence that the Earth has its own magnetic field. It always swings to point north because the Earth behaves as if it has a giant bar magnet inside of it. The field around a wire. Here's the big idea that links electricity and magnetism. Whenever a current flows through a wire, it makes a magnetic field around the wire, and the field lines are circles around it. Two things change the strength. A bigger current makes a stronger field, and the closer you are to the wire, the stronger the field. Reverse the direction of the current, and the field flips direction too. Solenoids and electromagnets. A single wire's field is weak, so we coil the wire into a cylinder called a solenoid. The clever part is that the field from every loop adds together, giving a strong, uniform field inside the solenoid. While outside, it looks just like a bar magnet, with a north and a south end. Put an iron core inside the solenoid and you have an electromagnet, and the iron massively boosts the field. The best thing about an electromagnet is that you can switch it on and off and change its strength, just with the current, which a permanent magnet can never do. That's why they're used in scrapyard cranes. They're also used in electric bells and door locks. In the exam, to make an electromagnet stronger, more current, more turns on the coil, or an iron core.